Okay. So in the last lecture, we had seen the concept of interface. So the interface is nothing but, as we know that the by default, the methods in interface are default, abstract, and the variables are finals. Okay. So that we had seen that, and what is the use of the interface, how they are overcoming the problem of multiple inheritance in C++. So that also we have seen. So in the today's session, we are going to see the concept of garbage collection. We are going to see the concept of garbage collection in Java. Basically, unlike the C++, here we don't need any specific mechanisms. Here we don't require any specific mechanisms for the garbage collections. Okay, because the JVM itself is providing the garbage collection activities, and they are managing the garbage collection activities simultaneously. Okay, for example, if you are doing a particular program, and if 50 bytes are allotted for you, and out of that only 40 bytes you have used, so 10 bytes will be automatically collected by the garbage collectors. Okay, and it is given for the other programmers whosoever it is required. Okay, so basically that is nothing but the management tactics which the Java is following. But we can provide a request to the compilers for the garbage collections to show the data which they have created. Okay, so basically here in this case, we have the two extreme concepts which are available. The first one is programmer is not responsible at all for the memory management. Programmer has to be very careful to please the garbage collection. Okay, so these are the two extremes. The first is programmer is not at all responsible for memory management, which the Java is considering. The programmer has to be very careful for to please garbage collections. But as far as a large, but we need to understand the garbage collections for the large scale programs. Huge, it has a huge impact on the speeds. Okay, so basically GC guarantees, it is nothing but the garbage collection guarantees. Java language specifications rather vague. Java virtual machine specifications. Basically, this is nothing but the standard methods which the garbage collectors of the Java has been developed. Heap is basically created at the JVM startup. So heap is created at the starting of the JVM. Whenever the JVM Java virtual machine is starting, then at that time the heap is created to collect the garbage values or the space which is not utilized among the programs. The heap storage for object is automatically reclaimed. Okay, heap storage for object is automatically reclaimed. So it is automatic, it is collecting the things. No explicit deallocation is required. No specific mechanism is specified. Okay, no specific mechanism is specified because whenever we are doing the program at the same time, it is making the job of collection. So no need of any specific specialized mechanisms to work on it at after the completion of program. Okay, so basically the life cycle of an object which the heap is creating is creation, it is in use, invisible, reachable, collected, finalized, deallocated. Okay, so it means that this is nothing but the life cycle of if you are creating an object or a variable. So initially we are creating those variables or those objects. We are using those. Sometimes invisible, it means that sometimes we may not able to use or we are not using those particular variable because certain other manipulations are going on. Then the unreachable, the system might be or that particular object might be unreachable. Then collecting the values, finalizing, and then final deallocation. So whatever the memory which is allotted for the creation, that is deallocated. Okay, so we will see each of them. The creation, allocate the space, begin object constructions. Okay, initially, as we know that if you are considering variables or the object also, we are allocating the space first. Whenever we are declaring, we are allocating the space. Then we are trying to construct the objects. We are calling the superclass constructors. That is nothing but superclass constructor is nothing but if it is the object of a subclass, then at that time automatically superclass constructor is automatically getting called. We are running the instance initializers and instance variables initializers. Okay, so this is basically used as a work of constructor. Just like a constructor, it is used to initializing the value, executing the body of a constructor. Okay, so this is nothing but the creation. As we know that creation, in that case, we are creating, allotting the space, and we are making the initialization. So that is nothing but the creation. In use, held by at least one strong reference. All references are strong unless we explicitly use one of Softwick or Phantom reference, see, that we will see afterwards. Okay, basically this is nothing but the object creation. Okay, after object creations, automatically the constructor is getting called, initialization is happening, and after initialization we are using that. Okay, so this is nothing but the basic function which we are following. Okay, the invisible, no strong reference left that is accessible to the program, but there are still references, local variables that have gone out of scope. Okay, so this is the another case. In that case, that there is no strong reference left. It means that the maximum times we have used those variables, whatever the changes that we would like to make to that variable, that we have already done. Okay, but right now, afterwards, certain local references are remaining, so that we are just considering. Okay, just if you are considering the try catch while true, it is just going inside. So something is missing or something is remaining, so for that, that particular object is not used. Okay, unreachable, it means that that particular object is not, or it is going out of scope, no more direct or indirect. So it is nothing but when we are going to go for the garbage collection, so that if the particular object is unreachable, we are just collecting that object automatically. No more direct or indirect strong reference. Okay, so there is no any reference for that object, so directly we are collecting it into the heap. The system itself is maintain it into the heap. Okay, so then after that, collected, finalized, deallocated. So that is nothing but it is uh, collected. So garbage collector. So as we know that the particular object is unreachable, which is not reached or which is not accessed by any of the methods of a particular program. Then at that time, that is collected by the garbage collector. Okay, after collecting, they are finalized. Okay, with the help of the finalizers. Okay, and then we are deallocating the space. Finalizing, it means that we are checking that really is it not is news, and then we are deallocating the space. If the collector finds an object unreachable, if the collector finds an object unreachable, okay, if it has a finalized method, mark for finalization. Okay, if the collector finds an object unreachable, if it has a finalized method, mark for finalization. So it means that final deallocation will be filled. Finalizers have been run to finalized. No guarantees about when it may actually not even run before terminations. Finalizers are rarely a good idea. Okay, so it means that directly deallocating, instead of directly deallocating that objects with the help of the finalizers, we are just checking that whether the working of that particular object is over or not. Okay, so deallocation, that is nothing but the reusability of the space. So again, that space can be used by some other programs. Okay, so that is nothing but, so therefore, just because of this, we don't need to write the destructors. Okay, we don't need to write the destructors because the work of destructors is handled by garbage collector itself. Automatically, it is checking if the particular object is unreachable. Automatically, it is marking those objects and it is given for the finalizing. And if the finalizers will give the remark that that particular object is not in use or it is not useful, then automatically that particular will get destroyed. Okay, and that particular object is discarded and the memory is freed, and that memory could be used for another work. Okay, so reference object is nothing but the object which is referenced by some other objects. Okay, So the java.lang.reference to help the tune, it prevents the leaks. Soft, weak and phantom reference queues. Soft reference for implementing memory sensitive caches. Weak reference for soft reference is nothing but for it is implementing memory sensitive cache. Okay, it means that that particular reference object is nothing but it is an object which is containing the related informations. Okay, soft refers, it is used for implementing the memory sensitive caches. The weak reference for mapping where keys or values may be reclaimed. Okay, so reachability. So basically, these are nothing but reachability is nothing but it is strongly reachable, only strong reference from root set. So basically, it means that the reference is provided, but whether that particular object is reachable from the current object or not. So that we are just going to consider. The softly, it means that may be reachable, may not be reachable. Okay. Weakly, neither strong nor soft, but live weak reference will be collected and reference is set to null. Okay, so these kinds are just directly collected and it is set to null because there is no connectivity. The chances of less connectivity or no connectivity is there. So therefore, we have to reclaim that particular space. Okay, neither strong, weak, nor soft and has been finalized. Okay, else unreachable. It is nothing but, and if it is unreachable, obviously we are collecting that space, we are freeing that space and we are using it. Okay, so we are reclaiming that space. Okay, so this is nothing but the stack heap thread active thread, so that we will see afterwards. I think this much is sufficient as far as this session is considered.